I'm back. There's not a shortcut that I can do here. If you try to do this, integrating something with tangent, you're going to see there's nothing that has just tangent as its derivative. So we really can't do this one that way. So the trick to this one, and it is a trick, is to break this up into tangent to the 8th x times tan squared x. You always want to have a squared here because now we can use one of the Pythagorean identities that involves tangent. And if you look, Pythagoreans are right here. Tan squared would equal secant squared minus 1. Let's do that. So it's tan to the 8th x and then secant squared x minus 1. The reason, remember, we just want to end up with a reduced power of tangent. Now, when I distribute this, we're going to get tan to the 8th x secant squared x dx minus the integral of tan to the 8th x dx. Okay, that integral is okay because it's a reduced power of what I started with, and that was my whole goal on these is a reduction formula. I want to end up with a reduced power of tangent, and I've got it. Here, if you remember, tangent's derivative, the reason why I did this, tangent's derivative is secant squared. Now this is actually a power rule. Think about this. You can do power rule, in other words, you can add one to this if you have the derivative of the inside attached to the dx, and that is the case here. I can attach the secant squared to the dx, throw it away, and do my power rule. So I'll have tan to the 9th x times 1/9 minus the integral of tan to the 8th x dx. Now I've got a reduced integral of tangent, and that was my goal. Okay, so my reduction formula remember, I'm guessing what the nth case is. We're going to prove it in a minute. N is a 10 in this problem. So I am guessing that the reduction formula for tan to the nth, is, keeping 10 as n, I've got a 9, so that's n minus 1. So it looks like 1 over n minus 1 times tan to the, again, n minus 1 x minus the integral of tan. This time I've got an 8 compared back to my 10, n minus 2 x dx. Okay, so our goal this time now is to repeat this whole problem starting with the nth case and see if we can get this. So tan to the nth. So again, the trick here was to not do the integration by parts because there's nothing that has tangent that I can integrate with tangent. So what we did was rewrite it so that we could use one of the Pythagorean identities. So I did tan, and I wanted a tan squared, so I'm going to take off a tan squared. That will leave n minus 2 here. So if I had n, and I'm taking off a tan squared, that's n minus 2. Now I'm going to do Pythagorean identity here. So tan to the n minus 2. And again, it's just looking back to see what's happening on step by step and doing it with the nth case. But here I've got the tan squared, here I have the tan squared. So it's secant squared x minus 1 dx. Then if I look, the next thing I did was distribute the tan to the 8th in. So tan to the n minus 2 x times secant squared x dx. So just distributing there. And now to the minus 1. So minus the integral of tan to the n minus 2 x dx. All right, just about there. Here I can I actually can integrate this because I can think of it as a power rule. Again, this is tan to the n minus 2. The inside derivative is secant squared. So now I can apply the power rule here, where I add 1 to that. So if I add 1, that will give me n minus 1. So I have to multiply by that reciprocal, 1 over n minus 1. And minus the integral tan n minus 2 x dx. So let's see, 1 over n minus 1, tan to the n minus 1, minus integral. Got it. Okay, not too bad. Okay, the last one. So tangent didn't require integration by parts. The last one I am going to do with you, and I'm only going to do the numerical one, is the cosecant. So example 5. The integral of cosecant to the, let's go, 8th power x dx. Okay, this one can be done with integration by parts. So u dv. So we want to know, what can we integrate here? So with cosecant squared, it looks like if I have a cosecant squared, the integral of that is cotangent. So I'm going to take a cosecant squared and pull it over here. That will leave a cosecant to the 6th here. Okay. Integrating. Again, cotangent's derivative is negative cosecant squared. So the antiderivative here would be negative cotangent x. Here, doing derivative with a power rule, the 6 comes down, times the cosecant to the 1 less power, times the derivative inside. Cosecant's derivative is a negative cosecant cotangent. Okay. Simplifying this here, we'll have a negative 6. I can combine my cosecant to the 5th and my cosecant to the 1st and come back to cosecant to the 6th x, cotangent x. Okay, so I multiply here and I integrate here. Plus, minus, that's a bad integral. Alright, so the integral of cosecant to the 8th x dx equals cosecant negative cosecant to the 6th x cotangent x. And then here I'm going to have a negative and a negative, 3 negatives there, so that's going to make a minus. The integral of 6 cosecant to the 6th and cotangent squared. Okay, again, I want an integral with just a reduced power of cosecant, so I'm going to use that Pythagorean identity again, because I'm pretty sure there's one that relates cosecant and cotangent. And here it is. I've got a cotangent squared, so cotangent squared would equal cosecant squared minus 1. So using the Pythagoreans, I need cosecant squared minus 1 there. I'm going to ditto that. 6 cosecant to the 6th, and then cosecant squared minus 1. Ditto that. Okay, I've got a negative here to worry about. I'm going to make this a negative 6 that I'm going to distribute so I don't lose that on my second distribution. So that will give me minus the integral of 6 cosecant to the 8th x, then plus 6 cosecant to the 6th. Okay, This is perfect because it's only a reduced power of cosecant, which is what I want. This matches my original, so I can add it back to the other side. So I will be adding 6 cosecant to the 8th x dx to both sides. So 6 of these integrals plus the one that I started with gives me 7 integral of cosecant to the 8th x dx. So we're just about there. Negative cosecant to the 6th x, cotangent x. That's gone. Plus the integral of 6 cosecant to the 6th x dx. All right, I'll just have to divide by 7. So that will give me a negative 1/7 here. So give me a 6/7. So just guessing what the reduction formula is in terms of n, knowing that n was an 8 here, looks like I've got negative 1 over n minus 1 cosecant to the n minus 2 cotangent x plus the integral of, let's see, I got a 6 and I start with an 8. That would be n minus 2 over n minus 1 cosecant to the n minus 2 x dx. So if you look, all 3 of the ones we did today involved using a Pythagorean identity. 2 of them worked with integration by parts, and the tangent was the only one that did not. So don't expect cotangent to use integration by parts either. All right, so your assignment tomorrow is going to be to pick up the nth case here. That is problem number, let's see, the cosecant one. Let's see, we are on page 449. They start. The nth case for this one is number 11. If you want to start with that one, you can finish up. And then the other ones you have are let's see, what did I do here? I got to see which ones I did. I started with, where did it go? Let's see, cosine. So you've got that. So that would be number 1. And 7 go together. Because this is a numerical one. This is the nth one for cosine. Cotangent is number 3, the numbered one. 9 is the numerical one. And then secant is 5. And then the nth one is 12. Okay, I don't care what order you go in. So 11 matches this one. These 2 are paired up, these 2 are paired up, and these 2 are paired up. Okay,